I thought I would try to reproduce the start of our Zoom session this morning when I forgot to turn on the recorder. And so what I started out with was saying that in homework 7, what we're trying to do is to determine if we can cut off one of the extra bars that are in both the positive and negative moment. And the first step in this bar cutoff is, do you have any extra bars, H? And we have one extra negative bar there. We have one extra negative bar, and I think I've been using blue for all the negative moment. And we have one extra positive bar there. And we want to know if we can cut them off. And then to give you context for the problem, what I said was that there's the moment diagram, and the three positive bars, these here, were designed for this maximal moment there. But when you get below a certain value, so let's say this is, in fact, I had those values here. When you cut off one bar, one positive bar, the capacity goes down to 180. And so I was saying that when you get below 180, so here, everywhere here in the moment diagram, that's below 180. All out here is below 180. And so you don't need the third bar out in those wings. Similarly, you have 3 negative bars, and when you cut one out, the capacity goes from 122 down to 83. So anywhere the negative moment is less than 83, you don't need that third bar. And so, I roughly out here and out here, you don't need that third negative bar. And that's what we were trying to figure out for this problem. And then I turned on the recorder, and the rest of this follows. And I'll paste this little section in front of when I started to do the recording. Okay, so it's recording now. Okay, so what we're gonna do, let's see, that stuff erased. Oh, it did. Okay. What we need to do is determine if we can cut one of the positive bars and determine if we can cut one of the negative bars. And if you can cut them, how long are the bars to the nearest 3 inches? And then make a drawing, and the rest of this is, these are additional things. So this stuff here, I'm gonna save that till Wednesday. Okay, so we'll do everything except that today, hopefully. Okay, so this is how it works. So you HELP, H, have any extra bars. So you look at this, and we have one extra bar, okay? Because you can't cut out 2 bars because you have to have a minimum of 2 bars to put in the corners of the stirrups. So we have one extra bar, okay? Okay, next, E, establish where you don't need them. Okay. So let me do this again since we're recording. So this time I'm gonna record an extra one. Copy the moment diagram. paste it on top of this thing. I have an extra one, right? Yeah. So I've eyeballed that moment diagram to scale to the length of the beam. Okay. And what we want to know is when the moment gets smaller, so you see out here where the negative moment is small, we don't need that third bar out where the moment's small. So we need all three bars only in the middle part where the moment's big. And the third bar is not necessary on the wings of the moment diagram. Okay, so we're wondering if we can cut that off. The same thing for the positive moment. We're wondering, I'm just making this up, out here, in the wings where the moment is smaller, maybe we don't need the third bar. Okay, so in the middle, we need all three bars, but out on the wings, maybe we only need 2 bars. And what we need to do next is find where are these spots, okay? So that's E. Okay, so the question is, let me blow this back up. Let's do the positive moment first. Where do we not need that third number 9 bar? So you would have to know how much is phi mn with only 2 number 9 bars. And to save you time, because you know this used to be like on an exam, so it was time. I did this for you, but you know, you just do T equals C, solve for A, Z equals D minus A over 2, Mn equals T times E. Oh, by the way, I finished grading all of problem 1, and I think problems 2 through 4, they'll go faster because there's just one answer. Most of you did very, very well on problem 1. So, anyway, 2 number 9 bars, phi mn is 180 foot kips. That's where you don't need it anymore. So let's go to the moment diagram. Okay. Make this as big as possible. I've already forgot. What did I say? 2 number 9 bars is 180. We're looking for 180. Well, the other thing is, so the moment diagram had better not be bigger than 260 or we designed it wrong. So 3 number 9s can hold 260, 2 number 9s can hold 180. So that's good. 3 number 9s hold 260. So the moment diagram's below that, but the other one we need to find is 180. My computer, my laptop sounds like it's gonna explode. I think the recording is. Okay, so I'm gonna just draw a line across there. I'm gonna make the line thicker so you can see it. Try and draw that straight across. Perfect. Okay. It's a little too fat. I can't see exactly where it's crossing. I'm going to make the line thinner.
take my glasses off to see this. Okay, that's where you do not need the bars anymore. Still got this too fat. Okay. I call that theoretical cutoff point. Okay. You need to add to that, to be safe, D or 12 bar diameters. So let's find out what D was and what 12 bar diameters. The height was 24, so D is 21.5. I'm going to change that to feet. .79 feet. Bar diameters. Okay, this is a weird thing. A number 9 bar is not 9/8 of an inch in diameter. So what you need to do, I have, you know, that chart that tells you how much steel 4 number 9s are, 3 number 9s. In the very top row, it has the diameter of the bar. And the diameter of a number 9 is actually 1.128 inches. It's kind of sad that I have that memorized. .54 inches. Less than D. D is almost always the biggest. Okay, so 1.79 feet. Oh, there it is. We have to add extra 1.79 feet. And so what you would do, need to get a piece of paper and mark off 1.8 feet. I'm just gonna do it using my pencil on here. So it's from there. I'm just gonna eyeball this to there. That looks like 1.8 feet to me, okay? That's 1.18 feet, D. Now I realized I can copy that. Oh, you know what I can do? I can also make it a different color. Green. Oh, copy that. Paste it there. Okay, so what I've done is theoretically I could cut it at those orange dots, but to be safe you have to go extra to the green dots. Let me draw a dot in. That's where I'm going to propose to cut it off. Next, we need to check the development length. From there to the maximum of the moment diagram needs to be at least LD. And so we either eyeball in the maximum of the moment diagram, or I remember one of the useful things in this table, the maximum moment positive happens at 17.8 feet. So that's pretty handy to know, 17.8 feet, okay? $17.8 feet, right there. Oh, wrong diagram. 17.8 feet. It's super nice that my drawing program will snap that line straight. So there's the maximum. Okay, next, so that's E, establish the cutoff points. Next is LD. We have to check the development length. Okay. So what I've posted, and I've pasted in here because I knew I was going to do this, is this. So I've made this nicer so it's less ambiguous to use this chart. Okay. If you are number 6 or smaller, you use the left column. If you're number 7 or larger, you use the right column. We have number 9, so we're using the right column. If you have good confinement or spacing, use the first row. And then I define exactly what this is. And so minimum stirrups, so we are the first row. This is the equation. And I've decided the old table had LD divided by DB. It was confusing people. I just put the DB on the right-hand side of the equation. So this is the development length right there. That's all we got to do. So let's calculate that. 120. Oh, you know what? If I don't have any ink on here, I can copy it. I've learned that. As long as there's no ink, I can copy stuff. So I'm going to copy this equation, paste it up here with all the information. Okay, that's the equation. For the number 9 bars. We're going to have to do this again for the negative moment, which are number 6 bars. Okay. Lambda is lightweight concrete. Normal weight concrete, so it's 1. Fy is 60 KSI, but this equation is in PSI. And the reason this equation is in PSI because it has a square root of F prime C. So you cannot put 4. It has to be 4,000. Okay. Psi sub T, T stands for top bar. For the positive moment, the bars are on the bottom. Psi sub E is if it's epoxy coated, and so all these things are down here. Psi sub E, psi sub T, all that stuff. Psi sub E is if it's epoxy coated, and it specifically says not epoxy coated. Psi sub G is the new one. I actually can't remember, so I'm going to look at that. That I know it has to do with the Fy. So Fy is 60. Okay, psi sub g. If it's grade 60, it's 1.0. Okay. So that's new for 2019. Times the diameter of the bar. You know what? I should show you this. And I know I can swipe left, but I have several of your graded exams in the left column, so I don't want to do that. So on this table, there's the diameter of the number 9 bar, 1.128 inches. So this this table is handy. I've also made this table a little nicer. You get your choice of how much space you want to put between the bars, because for the epoxy coated bars, if you put them 3 diameters apart, you get a lower development length factor. So this is the new spacing table. It's a little fancier. I didn't want to confuse you. I just gave you, the old table just had that first row, the narrowest it could be. But anyway, 1.128 square diameter for number 9. And I am going to quickly do this. Yeah, nobody saw. Okay. 1.128. Okay, so we just punch that all out and see what happens. And this will be shockingly large. 60,000. $53.5 inches. $4.46 feet. I didn't think it was, I'm gonna double check I didn't mess up. No, that's right. This means you have to put a number 9 bar 4.5 feet into the concrete so it won't slip out. That's a lot. Okay. So 4.5 feet. .5 feet from there, yeah, all the way to there. Make that purple. Okay. So the question is, what you're trying to check where you're proposing to cut it off to the maximum moment, is that, because it has to be 4.5 feet or it's going to slip. Okay, that is greater than 4.5 feet. Yes. Okay, and this is symmetric if I copied everything right. So let's see. Oh, close enough. Okay. Yes. Well, let me put that over there. Okay. So those are good. The other thing, this is the harder thing to do, is the bars you are not cutting. So if you can remember the picture, the bars that go all the way across from support to support go from here all the way to here, right? Because where that moment diagram kinks, that's the support. Those are the bars that are not being cut. The distance from where you want to cut them to the theoretical cutting point has to also be LD. And this looks close. This one doesn't look close. Okay, so we need to check those. That's okay, and the other one obviously will be okay. Oops. Put it down here. Okay. So you are allowed to cut at our proposed cutoff points. Everything checks out. And the last thing to do is round those to the nearest 3 inches. I'm gonna say that's at 7. Well, of course that's at 7 feet. That's the support. This one here. This one here. This is totally just your call. And remember, oh no, don't do that. Remember, if you're gonna round anything, you wanna round the bars longer. Okay. So you don't want to make the bars get shorter. You want them to round longer. So this point right here, I'm gonna say that's 11 feet 3 inches because that's rounding that way to make it a little longer. 11.6 would make it shorter. I'm gonna call that 24 feet 3 inches. Okay. So in the end, 24.3, 11.3. That's where you're gonna cut that third bar, which makes that third bar a lucky 13 feet long. because remember, my wife's birthday is on the 13th. So there's no unlucky 13th for me. Okay. Let's repeat this for the negative moment and then see what we get. And we'll stop at 10:50, and if we don't finish, we'll finish this on Wednesday. Okay. So the negative bar are number 6s, so that's going to affect the development length. And if you cut one of the number 6s, you go down to 83. Okay, so 122 is the full strength, 83 is the reduced strength. 122 and 83. Okay. So zoom that in. 122 and 83. And I think I will do, I was using some kind of color coding, blue for negative. Okay. Missed. I'm gonna nudge that up a little. Okay, that, to the best of my eyeballs, is 83. I guarantee you that D is bigger than 12 number 6 diameters because it was bigger than 12 number 9 diameters. So D is greater than 12 bar diameters. So I have it right here. There's D. You would do this on a piece of paper. Oh no, but you can do this on your iPad if you have an iPad, so you can do it exactly like how I'm doing it. I gotta take my glasses off here. Okay, we also have to do the bar that we're not cutting. So the bar we're not cutting goes all the way to where the moment's 0. And just a reminder, I might be wrong, so we better double check it. That's D. 12 bar diameters or L over 16. So we need to find the length of that span. Let me go double check. That's less than D. So D is still the biggest, okay? Okay, next, we had one extra bar, H. E, we established the theoretical and proposed cutoff points, L, LD. Okay, the negative bars are number 6. So it's number 6 or smaller. So we're using the first column. It still has minimum stirrups, so we're using the first row. We're using the 1/25. This one. I'm running out of room. I'll do it up here. Using that one. Still like a normal weight concrete, 4,000. Okay, these bars are on the top. If there's more than 12 inches of concrete below the bar, all the bubbles will float up under the bar and it will reduce, it'll increase the development length. So this is a top bar. I can't remember what the penalty is, so we gotta go read that. Top bar 1.3 if you have 12 inches of concrete below the rebar, so 1.3. Not epoxy coated. Grade 60. And a number 6 bar is 0.625 inches in diameter. You can double check it, but that's true. Okay, this might be smaller because the diameter is almost half, but it has that extra 1.3, but it has a 1/25. I'm pretty sure this will be shorter. Let's see. I get 30.8 inches.
Is number 6 bar 0.75 inches?
Oh, that's right. A number 5 bar is 0.65. Oh man. So don't try to do it by memory. Well, numbers 3 through 7 are by 1/8 of inches, so it's 7/8. So 37.0 inches. .08 feet. Okay. Oh, that's close. It's okay. This is not symmetric. Okay. Pasted that right on the wrong spot. Okay, so that first one is good because that was greater than LD. Can you see the left one? Because it was steeper, is no good. This is too short. The development length from the maximum to the development length is longer than what you have. The bar would slip out. So that's your new proposed cutoff. Okay. The ones you aren't cutting off, from there to the theoretical cutoff point. Oh, the ones you aren't cutting off, which is way out here. From there to the theoretical cutoff point, not even close. Okay, that's bigger. The one on the left is a little close. From here to the theoretical, well, it's not as close as I thought. That's definitely bigger than that green line. Okay, final thing. We'll go 1 minute over. We have to round this to the nearest 3 inches. Um, 3 foot 9 inches. 10 feet 6 inches. I'm gonna call that 15 feet 9 inches. Make it a little long. It might be 15.6, but I'll call it 15.9. Okay, we will do the last part of this problem on Wednesday, but this is exactly your homework. Okay, so if you can watch this video and reproduce it, that's your homework. Okay. Make sure you can do it because it's also your test. I'm just going to change the numbers. Okay.
We were a little rushed at the very end of the Zoom session today, and so I thought I would re-record the very last little bit. So we had gotten this far, and what we were doing was finding the final lengths. And so let me do that. So here we see that we decided to cut here, and I made a mistake in the previous video. I picked this spot, but the bars were not cutting, they're going in there. And so what I needed to do was to find those distances to the nearest 3 inches and round everything longer, not shorter. And so this one here, I said was 3 feet 9 inches. This one here, 10 foot 6 inches. And in the previous video, I did that by accident. This is the one we need to do here. And that is 17 feet 6 inches. Similarly, for the positive moment, obviously the bars you're not cutting go from the support to the support, 7 feet to 28 feet. And the ones we are cutting, we were going to cut here, which was 24 feet 3 inches, and here, which was 11 feet 3 inches. Okay, what I thought I would do is I've tried to put that all up here in this drawing up here. And so here are all those dimensions. And so the negative bar goes from the left end all the way out to 17 feet 6 inches, which makes that bar 17 feet 6 inches long. And the bar that's cut is going from 3 foot 9 inches to 10 foot 6 inches. And if you subtract that, that bar is only 6 feet 9 inches long. And for the positive moment, the bars that are not cut go from 7 foot to 28 feet, which is that 21 foot span. So the bars that go the whole length are 21 feet. And the bar that's shorter is going from 11 foot 3 inches all the way to 24 foot 3 inches. And that came out to 13 feet long. What I did was what I'm going to do is I'm going to show you a video with my camera where I show you what this looks like. I'm going to try to show you this in 3D.
What I've done here is printed out the work we've done, but I have a black and white printer. So what I had to do was just go over the positive bars with an orange Sharpie. It looks red in my camera. And the negative bars with a blue Sharpie. The first thing I want to point out is that the negative moment bars, even though the moment diagram's on the bottom, you know, the tension is in the top. And so the negative moment bars are in the top, and the positive moment bars, even though the moment diagram's on top, the tension's on the bottom. So the positive moment bars, the orange bars, are on the bottom. The other thing I've done is I've cut some barbecue skewers, and I colored them orange and blue, and I've cut them to length. So for example, there's one positive bar, the longer one. And that's the shorter positive bar. And the reason I've done this is I want you to visualize what the steel looks like from the top view. And so the top view of the positive steel will look like this. Okay. So there are the 3 positive bars. And out here, where the moment is smaller, you see you have only 2 bars. And in here, where the moment is larger, you have all 3 bars. Okay, this bar here, I can't remember. Well, we said that bar was 21 feet long. And we said that that shorter bar, this bar here, was 13 feet long. And if you figure it out, I think the distance from here to the edge of that bar, let's see, it was 3 feet 9 inches from the middle of that support to the edge of this bar. Okay, that's the information you would need to know to build this beam. Okay, for the negative bars, which I've color coded blue, I did the same thing. So here's one that is, oops, that long. Let me center the paper. Okay. The longer bar. I've got 2 of those. And the shorter bar is just that. Okay. And then we determined that this bar is only 6 feet 9 inches long, and this bar was 17 feet 6 inches long. Okay, and those bars will go like this. So on the top of the beam, the top view, you have this, this, and that. Let me try to get that straight. and in the right spot. There we go. Okay. And so those negative bars, okay, that bar again was 17.6. That bar was 6 foot 9 inches, and this bar started 3 foot 9 inches from the end there. Okay, so if you can imagine, these bars are in the bottom of the form, and these bars are in the top of the form. Okay, and so how is that middle bar going to be held up in the air before you pour the concrete? You're going to have to tie something around there to tie that up. These will be sitting in the bottom of the stirrup. These two will be in the corners of the stirrup. So I just wanted you to be able to visualize what the reinforcement would look like in this beam. So I hope that helps.